From the heart of Orlando, Florida, you are listening to the most electrifying show in media, A Neighbor's Choice. And I'm your host, your neighbor, David Gornoski. So glad you could be with me once again for our Science and You segment we do each Thursday evening at 8. So glad you could be a part of this program on 93.1 FM as well as 540 AM all across Central Florida, across multiple counties, all over the place. And I know we've got a lot of great people who are very interested in science and innovation and technology, people who are doers themselves, people working in academia, people working outside of academia. And we want to bring these people on each week. And joining me for my Science and You segment is my Chief Science Advisor, Dr. Wei-Ping Yu.
Thanks, David, for having me again.
And so glad to see you. I know you're very busy solving all the physics problems, but you're very humble, so you would never, you never see you down or sad at all. You're always upbeat and ready to go, aren't you?
Yes, I'm excited, especially today, for your two important guests.
Yeah, I was very interested in this subject because we like to explore not only the cosmos on this show, but also we want to explore things like how energy works and how medicine works and things outside the box for curing big diseases. We had Dr. Aubrey de Grey on a couple weeks ago, who's one of the foremost researchers in solving anti-aging and approaching the idea of aging cells as a disease that can be mitigated and even reversed potentially in the next generation or so. But we also like to explore interesting questions about humans and how we relate to Earth. And so the idea of human magnetism has been around for some time, but it's got a lot of misnomers, a lot of sensationalism tied back to it. So a lot of people don't even, is it too, they don't want to go into that topic. But actually, there's scientific discoveries being done, and I was excited to have these two guests on because they've been involved with doing that. At Caltech University, the Division of Biology and Biological Engineering and the Division of Geological and Planetary Sciences at Caltech have come together with a team of people, and they've explored how the human mind, the human brain, is affected by Earth's magnetic sphere. And so joining us to discuss this is the experts themselves. I saw them recently. They were on drudgereport.com, which means lots of people are being exposed to their ideas for the first time, and we wanted to unpack those ideas with them. So I'm with Dr. Joe Kirschvink, who is a geobiologist over at Caltech, as well as Shin Shimojo, who is you work in neuroscience and psychophysical studies. That's very interesting. Thanks for being on the program.
You're welcome.
Hello. Hi. Hello. Shin Shimojo here.
Very good. So I wanted to start, Dr. Kirschvink. I've been very fascinated to learn about your study, and I wanted to kind of give people an overview about what the latest findings were that Drudge Report, one of the top news sites, and many others have been covering.
Well, actually, this is a joint project between my group and Shin Shimojo's group here at Caltech. I've been interested in the way that animals make tiny crystals of the magnetic mineral magnetite for many years. It was first discovered here at Caltech by one of my predecessors, Heinz Lowenstamm, mineralizing the teeth of primitive mollusks, the chitons. And he made this marvelous discovery back in 1960-61 that the teeth of these little mollusks could be dragged around with a magnet. They were made of magnetite. It was later discovered in the magnetic bacteria, and I got interested in that when behavioral data for animals got better and better, showing that homing pigeons and honeybees and many, many other animals now use the magnetic field. So it's the obvious way of doing it, use a magnet.
Very interesting. And Dr. Shimojo, you're the partner here at Caltech studying how our human mind is affected by Earth's magnetic sphere. So tell us a little bit about your approach. What were you doing when you did this study with Dr. Kirschvink?
Sure. So one of our lab's, interest is to dig out implicit ability from human brain, even if he or she are not consciously aware of things. So in this case, it is the magnetic field change, which nobody directly feel as the sensation, like, pain or, color of red or stuff like that. But there's this signature defined by EEG, which is, basically brain waves, called alpha oscillation suppression by sensory detection. So avoid just two technical jargons. Basically, we have a way to define if brain responds to particular systematic shift of magnetic field, which was provided by Joe Kirschvink's lab as a stimulation. And we do measure from electrodes from the human scalp to see if him or her brain responds systematically to biologically realistic magnetic field change. And we found this thing called alpha ERD, and it's basically a suppression of alpha oscillation, which is known as a signature for sensory detection by vision, by touch, audition, and in this case, the new sense of magnetic sensation.
So, Dr. Kirschvink, so you put human beings in a little magnetic cage, right? And you're monitoring their brains to see if their brains can respond to the certain magnetic fields that you generated in that enclosure, correct?
Yes, Dave. What we were trying to do is to mimic the magnetic rotations that you would experience just by turning your head left to right or nodding it up and down. So many past physicists have attacked this problem by saying, oh, gee, the magnetic field is so weak, let's crank it up many times so that these poor animals have a chance of detecting it. That's actually the wrong approach. The magnetic field is very easy to detect if you have specialized cells with magnetite in them. And if you crank up the magnetic intensity, it's suddenly an unnatural condition. And the programming in the brain has said, well, it's not natural, it's probably a lightning strike or a magnetic anomaly, ignore it. And so most people go away saying it's ignored. What we tried to do is to give a very simple stimulus, just a short, brief rotation, not strong enough to cause electrical induction artifacts too much, but just like you would experience turning your head. And that worked.
So there was a brain reception that was affected by the magnetic fields. That was your discovery.
Shin can describe that better than I can, but yes.
Shin, can you break that down for our audience? What did you find with the brain analysis?
Yeah. So first of all, you need to know that there's this spontaneous fluctuation of brainwave called alpha oscillation. And this is happening to you, everybody, when you are not paying attention and just mind wandering, the oscillation is strongest. When you detect something, such as somebody touched you, somebody said hello to you, then all of a sudden this alpha oscillation is suppressed. And this is considered a signature for sensory detection and, paying attention to that stimulus. And it's been known across audition, vision, tactile sensation, stuff like that. So those are common signature of sensory detection across different sensory modalities. And this is the reason why we believe that this magneto-reception is a kind of sensation.
Yeah, very interesting. So Dr. Yu, on the other side of this break, will get into, from his perspective, he is a physicist, engineering physicist, and working in the aerospace field, but he has done a lot of interesting research about this topic, and so we'll get him on the other side to dive into this topic with you two. We're speaking with Dr. Kirschvink and Dr. Shimojo from Caltech, understanding human magnetism, how it works and how it relates to the Earth. We'll be right back in just a second. Neighbor's Choice Radio is back, I'm David Gornoski here, your neighbor, to dissect the things you don't hear every day, but the things that really affect us all. And one of those things is our relationship to the magnetic sphere of the Earth, understanding more about the human biological component. And I'm with Dr. Kirschvink and Dr. Shimojo from Caltech University, who they were headlined all over the world just a few weeks ago. Drudge Report and everybody was featuring them because they are doing really groundbreaking studies showing how the human mind, the human brain, is affected and interacts with Earth's magnetic sphere. So I wanted to turn it over to Dr. Yu, my in-house science advisor, to interact with some ideas.
Oh, hi. So I'm very excited with the topic about the human magnetism. I think you guys did a great pioneer work, study human brain connection with the Earth's magnetic field. So I have a couple of questions. So I wanted to establish the connection between alpha wave with Earth's magnetic field. See if you can answer me this question. Say, so you are measuring the brain activity, the alpha wave, in that frequency range. Is that right?
That's correct.
That's correct. And we know.
Yeah, go ahead.
That's good. That's human alpha wave response. And we know the Earth has a natural frequency. Alpha wave, it's in the same frequency range as the Earth's natural frequency. Is that right?
Well, there's a Schumann resonance at about that, but the amplitude of that is far below what we think the threshold of this system is. They're quite unrelated.
So they are quite related or unrelated?
Yeah.
Okay.
Unrelated,
We don't know if human alpha is generated by that. It's probably not.
Okay. So
it's self-organization of dynamic activity in the human brain.
Okay. So good. So and in your test, you have you're changing, manipulate, you create an artificial magnetic field. Is that right? You are not blocked.
We create an artificial magnetic field that adds vectorally to the geomagnetic field. And we've done it very carefully so the magnetic field vector simply rotates in direction and keeps the same intensity. It's like turning your head relative to the magnetic field, except instead of turning your head, the magnetic field rotates.
Okay. So the magnitude-wise, the magnitude of your artificial created magnetic field, is that bigger or smaller than natural Earth's magnetic field?
No. We want to keep it exactly as natural as it can be. We're not trying to change the intensity. Okay. There's a whole different set of experiments that you could do with changing intensity. But we wanted to mimic the magnetic compass that the receptor cells would detect simply by moving the head.
Okay, so your device actually demonstrates you are able to detect the so-called very weak Earth's magnetic field. Is that right?
Yeah, that's right. The way I like to look at this, normally ever since you were a baby, you would raise your head up and the magnetic field would change direction relative to your skull. But you have a vestibular system. The brain, in fact, tells the muscles to move the head, and the vestibular system tells you your head is moving. And also the magnetic field has been moving ever since you were born, or even before you were born. And so you're used to that. In our experiment, this is the first time most people would sit in a room, quiet, and then the magnetic field would rotate, but your head didn't move. The vestibular system hasn't told it anything. And the brain didn't tell it to do it. And so, the system freaks out. What's going on? What's crazy? And what Shin has been able to show is that the alpha waves drop. It's a very powerful effect. It's not a weak effect at all.
Okay. So basically, you said
I just want to add that, basically the brain learned what magnetic field shift change is owing to vestibular and visual input and learning. It's called associative learning. But the question is, if we isolate magnetic field shift only, does the brain is capable to detect? And the answer was yes.
Okay. So
that means there must be a biological magnetometer connected to the human nervous system. There's not some junk that comes in. I mean, if I were to go up to a laptop and try to plug a video camera in, the laptop wouldn't be able to see the video camera unless there's software there to do it. What we're saying is there's a natural magnetometer, and the human brain has the evolutionary software to actually process that data and use it. It's part of our physiology.
Yes, I agree with you because I do believe human magnetism interact. That's how they can perceive direction, because it directly interacts with the Earth's magnetic field. That's true. Can your device detect the human if instead of you use artificial rotate your magnetic field? Why can you detect a human brain rotation? Use your device without your artificial magnetic field, because the natural magnetic field is still there, right?
Oh,
yeah. So that's the reason why. That's the reason why. Yeah, that's the reason why I mentioned about the contingent change in magnetic field shift and vestibular and visual shift in the natural environment. So when you are standing or sit down and rotate your head, north to south, south to north, of course, your magnetic field is changing naturally, but it does also coming with vestibular change. And when you are opening your eyes, then visual shift of the scene, and those are sensory changes which is detected by the brain, and the same alpha ER, the alpha suppression, is observed. So it's unclear whether the brain response to head turn is vestibular reaction or visual response, or it's really to the magnetic field shift. So that was the new aspect of this experiment. But again, to emphasize, there's no task for the subjects. They close their eyes, they sit down in a chair, in a cage. They don't feel anything consciously. So, this is only a very subliminal response from the brain.
Thanks.
Yeah, it's very interesting. So tell people some of the implications of this research for the broader public, what this might shed light in about who we are as a species and what we're capable of.
Well, I like to think of it as demonstrating that humans are part of Earth's magnetic biosphere. And I mean truly magnetic biosphere, having crystals of a magnetic mineral that interacts with the geomagnetic field. Now, we know from the study of magnetic bacteria, there are actually many different types of bacteria that do the same thing. They make tiny crystals of the mineral magnetite, or sometimes the similar mineral greigite, which is an iron sulfide mineral, that are tiny little bar magnets. And there's enough magnetite in those cells so that the cells are passive compass needles and they rotate into it. The amazing thing about those bugs, though, we now know the genetics, almost every gene, every variant of every gene that forms those crystals. And we can look at their evolution. And they're as primitive as the bacteria are themselves. So basically, from day one when the bacteria evolved, maybe 3.5 billion years ago during the Archean, they were magnetic. They were magnetotactic. They inherited that laterally. It's easy to lose it. There are many bacteria that are not magnetic. But the genetics and the history of those genes go all the way back to the Archean. And then if you look at more evolved organisms, we have eukaryotes, which are a hybrid amalgamation of a bacterium and an archaea. But we have single-celled protists, protozoa, that also make hundreds to thousands of these magnetite crystals. They've been seen only in the nearshore ponds and lagoons of Brazil, but they're very clearly eukaryotes making these magnets. We think those were our ancestors of animals. And we have so many animals now that also are magnetic and that we know use the magnetite as their sense, that, it's just a natural part of human biology.
Well, very interesting, folks. We'll be on the other side. We'll dive more into human magnetism on the other side. You're listening to A Neighbor's Choice. I'm David Gornoski. Hold on just a moment. Don't go anywhere. Hello, this is David Gornoski. So glad you could join me in my neighborhood here in Orlando, Florida. The problems we have, they're not that hard to solve. They don't take a rocket scientist, but just in case, we have my chief science advisor, Dr. Yu, theoretical physicist in the aerospace industry, and we're joined with Dr. Shimojo of Caltech University, as well as Dr. Kirschvink, learning about their breakthrough research that demonstrates our brain's connectivity to the Earth's magnetic sphere. And it's very interesting. He's got a lot of mainstream media attention, and I wanted to have them on to unpack some of the implications of their work. Dr. Kirschvink, you were doing that on the other side of the commercial, so tell us a little bit more about where do you think the average person who wants to know about human magnetism and what are some of the implications that they can take home from this research you're doing?
Well, we don't really understand all of the implications yet. Certainly, if we look at all of the other animals that we know use the magnetic field behaviorally, the most common use is just compass directions. I mean, dogs orienting themselves when they defecate, for example. In fact, dogs can be trained to sniff out a bar magnet that's buried easier than they can food. Cows and deer tend to line up north-south. We've known for 30 years that whales tend to navigate relative to the magnetic stripes on the ocean floor. So if there is a function in biology, even human biology, it's probably related to intrinsic ideas of orientation and navigation. Our human ancestors 10,000 years ago were hunter-gatherers. There was a very good reason to use magnetic fields for navigation and homing, if you could. It's a backup cue. It's not the only cue. There are many orientation cues. But it's maybe not used so much in our daily life. And maybe with modern technology, there are so many magnetic anomalies and noises in our environment, we may not be developed to use it from Earth like we used to be. Mm-hmm. But what we're saying is that the sense is still there.
It reminds me of a story that came out in ScienceAlert.com. It's called "Neuroscientists Say They Found an Entirely New Form of Neural Communication," wherein they separated two pieces of the brain, and they noticed that the discovery kind of offered some radical new insights about the way neurons might be talking to one another. And the quote, via a mysterious process unrelated to conventionally understood mechanisms such as synaptic transmission or gap junction connections. And this was from Case Western Reserve University. But they said it was a new, and they had basically, I don't know if you're familiar with this work, but it basically was saying that there was some kind of, it says the researchers have been aware that there are slow wave of neural oscillations whose purpose they don't understand. Does this have any, there's something here that might be connected with what you're doing?
Could I just respond to that? Yeah, sure. In a broader sense, how biological systems communicate within its own body or across different individuals would be an interesting question. And our contribution may be, albeit speculative, something to do with, for instance, think about the magnetic storm influences pigeon's compass. This is well known. Joe can explain this better, but the fact that a biological magnetic system is influenced or suppressed by magnetic storm means that at least it receives the signals. So this may be potentially opening a possibility of some sort of unknown biological communication, which may not be related to what you just mentioned, but right. That would be our contribution. And just as a side note, on top of what Joe said, I would like to also mention that our research has implication on how we consider modern life. Because as you may know, modern life is full of artificial magnetic field.
Yeah, artificial Wi-Fi and magnetic fields, cellular towers.
Music headphones, flights, cockpit.
Radio broadcasts, like what we're doing right now, yeah.
So Joe has measured these artificial magnetic fields, and sometimes it's astonishingly very strong relative to the
I
very subtle signals that we detect in the brain. Yeah, Joe, go ahead.
Yeah, I went through a consumer electronics store in Tokyo a few months ago, Yodobashi Camera. It means like a 10-story department store for electronics. They have something like 400 stereo headsets, from professional to cheap ones to earbuds. And I just took a little magnetometer up to those things. Virtually every one of them throws a magnetic field through your head several times stronger than the Earth's magnetic field. If we are actually trying subconsciously to get an orientation from the Earth's magnetic field, and we're wearing a set of headsets that overpowers that, we are in fact deactivating any subconscious magnetic sense we might have. Now, this might sound like, oh, well, so what? But, disorientation errors in airline pilots is a huge problem. The death spiral, various things. When a pilot is flying through a cloud and they lose track of orientation, there may be times when a backup magnetic sense is subconsciously helping to guide them. And if they've got a big magnet through their head, that system is a priori deactivated. So I would argue that maybe, certainly aviation headsets should be redesigned so they don't do that. Nobody's ever worried about it. But we don't know it's a thing, but, given the strong effects that just rotating the magnetic field around your head has.
Yeah, I mean, it
might not be a dumb thing to do.
I use headset for my radio show. Maybe if I take it off, maybe I'll even do a better job. We'll have to figure that out, experiment. Dr.
You're not orienting on when you're talking on the radio.
Yeah, that's true.
Among our experimental participants, there are huge differences. A lot of them don't have any response. And very few has a, very strong response, and we call them strong responders. What the difference is unclear, but one speculation is that it's maybe disuse in the modern life may attenuate the ability. The second possibility is that the amount of exposure to those artificial magnetic fields in the past, in the individual history, might matter. So those things are unknown, but empirically testable, and those are in a waiting list in our research and somebody else's research.
Okay.
Dr. Yu?
I think your research could explain one of the mysteries. In Asia tradition, we have a feng shui, right? So in the Asia tradition, we build a house always face north and south. The main entrance, face north, the back window faces south. What they find is if you sleep in the night, you aligned with, that's basically the Earth's magnetic field direction. North and south, you have a sound sleep. So this could explain why human resonant with Earth's magnetic field without disturbing it. Because now you say brain, cells, brain nerves has the magnetic effect. So that could be an explanation. I think that's could be useful.
Wei Ping, I would be a little cautious there. I mean, if you had asked me 5 or 6 years ago, I would have said, nonsense. But since then, a number of studies have been published that show cattle and deer tend to spontaneously line up north-south, and then the dog defecating study is wild, but maybe not so bad. But here's my question for you. In the feng shui, if you go to South Africa, where the magnetic declination is like minus 20 degrees west to north, do they line up with the magnetic declination, or is it north-south geographic?
That's a great question. If you go to
then in California, do they line up plus 12 degrees from east? I mean, this was what convinced me about the cattle, because when they actually looked on Google Earth and zoomed in and saw the cattle in the various pastures, the average alignment followed the magnetic deviation, which varies a lot from place to place on the Earth. And so I want to say, is this true in the Chinese feng shui?
That's a general.
We'll have to explore that more. We're taking a quick commercial break. I'm David Gornoski. You're listening to A Neighbor's Choice.
Baby, do you know what that's worth? Ooh, heaven is a place
Welcome back to A Neighbor's Choice Radio. I'm David Gornoski, your neighbor, and we're doing our Science and You segment, studying the question of human magnetism. Does magnetism have more insights into our origins and how we think and how we relate to the earth and other things? We know there are animals that have a magnetic sense, and they're able to guide themselves across using their reception to the magnetic sphere. But we're joined with Dr. Kirschvink and Dr. Shimojo, who have done some very great research and more to come, hopefully, related to human magnetism. And I also have Dr. Yu here, our in-house science guru for physics. And I want to turn it back to you, Dr. Yu, some more questions to kind of, land the plane here about some of the things we can learn from this.
Okay. I developed a theory called the theory of everything, called a universal particle theory of everything. It basically concludes that the so-called brain wave is nothing more, just a magnetic wave. However, in order for brain generate a magnetic wave, of course, you have to have a magnetic particles, right, in the brain cells. So yes. Your evidence directly correlated this theory very well. I have a question for you.
I don't know about that, but go on.
Right, yes, I know. This is a new theory. Of course, I just find out your evidence and your work directly related to this conclusion. We find that not only brain has a strong magnetic wave, however, the heart muscle have an even much stronger magnetic wave. Estimated like 5,000 times stronger than brain magnetic wave. So have you thought about studying the magnetic effect to the heart?
A couple things first. The brain waves are not generated, as far as we can tell, by the motion of magnetite crystals. Shin, correct me if I'm wrong, but people have looked at brain waves while people are in MRI machines. Is that correct?
Yes, you can say that. Yeah.
Well, okay, but here's the thing: the magnetic particles in your brain and in your body, when you go into a 1 Tesla or 5 Tesla MRI imaging machine, those crystals are not moving. They are pinned energetically, rotation-wise, to the magnetic field. They don't budge. They're not going to generate waves. They might interact with radio waves a little bit, heat up or something, but they're not going to be part of the brain waves. If they were part of the brain waves would stop when you went into an MRI imager. And I don't think they do. Correct me if I'm wrong on that, Shin.
Okay, so two things, right? So there are two things. One is whether or not brainwave was generated by some sort of magnetic waves in the brain or body, and there's no evidence for this so far.
Yeah.
And the second thing, however, is that magnetic field of any kind, artificial, would have any influence on alpha or alpha suppression, which is the evidence of magnetic sensation. And I think there's a good chance that that would be the situation.
Okay. Okay. So I have another question.
But I would like to, I'm sorry, I would like to add something positive related to Dr. Yu's comment about the whole body and brain. And the latest trend in neuroscience is to talk about mutual interactions between brain and body, especially like heart rate or breathing and stuff like that. And it's nothing to do directly so far with magnetic waves, but it's been known. And I'm trying to study the synchrony, suspicious synchrony between brainwave oscillation, fluctuation, and heartbeat, for instance, or breathing or gait walking rhythm related to the brainwave oscillation. So there are studies of mutual dynamic influences between body and brain.
Sure.
But I sincerely doubt that those are based on the magnetism from the magnetite.
So based on your understanding, so what is brainwave?
So there are neurons, of course, in the brain, which are aligned, not randomly oriented, right? So I assume that it's like an ellipse, more or less, and it's aligned perpendicular to the sulcus, which is sort of like the crack in the brain. And depending on the cluster, that will generate, so of course the neural spike itself is electric activity, so they get some cluster electric field and induced current and stuff like that in the brain, but it's not random because of the brain structure. And that was considered to be the cause of various brain activity, including various wavelengths fluctuation.
Okay, so what is the alpha wave? What does
alpha
wave made of?
Made of. So again, that's kind of unclear, but at least that functionally, it's been known that it's enhanced when you are quiet, calm, not paying attention to anything, and mind wandering, and almost getting sleepy and relaxed. Then alpha amplitude is higher. But strange enough, each person has very intrinsic alpha frequency. It's typically across from 8 hertz to 13 hertz, typically 10 hertz. But you have your own intrinsic alpha wave, which can be considered as like a idling frequency of your brain, and it's very unique to each brain. So you can imagine, consider alpha wave as like a dynamic temporal brain fingerprint of each person. But more than that, the generation mechanism is unknown.
Okay, so you consider the wave. So what is waving? So basically, is it mechanical waving or magnetic, electromagnetic waving? Something, yeah. I just want to make sure people understand that the alpha wave, what is that?
More like a network of cells that are signaling each other in some sort of loop, and it takes maybe a tenth of a second to go around the loop. It's certainly picked up all over the brain, and an electrode in the front can't pick up the signal from the electrode in the back, so it has to be kind of an oscillation in these little neural networks that go into synchrony over the brain when you're not doing anything. It's not a magnetic wave, certainly. It's probably not a chemical wave, but action potentials running in circles from cell to cell to cell to cell and back again are most likely the origin.
Yes, I have another question. I believe that's very interesting to me. Through your study of human magnetism, actually you have a theory talking about the origin. By study magnetism, you find that the origin of life on Earth. Is that right? The origin of life. Is that right?
Well, I don't know about origin of life, but certainly we have very good evidence now that perhaps maybe the last common ancestor of the bacteria, maybe the last universal common ancestor, may have been magnetic or magnetotactic.
Wonderful.
You don't find it in a group of prokaryotes called the archaea. Mm-hmm. We've never found a magnetotactic archaea, or archaeobacterium, as they used to be called. But certainly there are now 5 different phyla within the bacterial domain, all of which have the ability to make these chains. And when you look at the genetics of how they do that and look at the evolutionary patterns, they follow the genome of those bugs. There's no evidence of moving from one bacterium to another through lateral gene transport. And in fact, it looks like there's probably 50 to 100 genes involved in that process. Some of them are localized in what we call the magnetosome island, but not all of them are. And there's no evidence that that particular group of genes has ever been transferred from one bacterium to the other. So that really puts it back to about 3 to 3.5 billion years. It also tells us the Earth's magnetic field has been here continuously for that period of time. It has implications for the interior of the Earth. The core has been convecting. Earth's magnetosphere has been here for most of the evolution of life.
Well, very good. Go ahead.
Surprisingly, we're aware of it. So.
Well, very interesting. I've enjoyed this discussion. There's a lot more to research. I'm looking forward to hearing more about what you guys uncover with your research at Caltech. Thanks again, Dr. Shimojo and Dr. Kirschvink, for joining us.
It's a pleasure.
And folks, that's another edition of A Neighbor's Choice, Science and You. We've explored human magnetism. Magnetism may have some connection to the origins of where we came from. Very interesting stuff, folks. Only heard here on A Neighbor's Choice. I'm David Gornoski. Godspeed.